Okay, so today we're going to talk about inverse functions. Okay, and like I said, this is our last section in chapter 9. Ooh, get excited. Okay. You have known at one point, hopefully you still know, what an inverse function is. So take about 30 seconds to brainstorm at your pod together what you remember about an inverse function. Okay, your 30 seconds are up. Pod 1, what do you have for us?
Switch the x's and the y's and then solve for the y.
Switch the x's and the y's. How do you feel about that description? What?
Apt description.
An apt description. Okay? I like that you said switch the x's and y's. If we are finding inverses graphically, numerically, or algebraically, we are switching the x's and y's. Like, that's the process we're going to take. Okay? Okay, so first of all, this is the notation. Okay, look at, maybe I'll put a little space there. Nope, not there. Okay, f to the negative first. That is the notation for f inverse. Okay, and this is a description. Gosh, this got really. Instead of saying the x's and y's switch, that's still an apt description. I'm going to go ahead and describe that the domain of f becomes the range of f inverse. Okay, so our x's and y's are switching, which means our domain and range, they also switch. Okay, so you've done things with inverses, but now on top of that, we are going to find domain and range for functions and inverse functions. Okay, so I want you to be able to, bless you, understand that if x's and y's are switching, then domain and ranges are also switching. Okay. What I'm going to focus on, so I described three things, right? I described numerically, graphically, and algebraically. We're not even going to worry about numerically. That's how you were introduced to inverse functions last year, probably. Okay. We're going to talk a little bit about the graphical part of it, and then we're going to focus a lot of our attention on the algebraic part. Okay. I know that you have found inverse functions last year, but we're going to do some examples that are a little bit more algebra intensive than what you did last year. Okay, we're going to beef it up a little bit. So first, let's talk about this. Here I have a function. Probably recognize this function. Okay. And we want to find its inverse. Okay. Pod 1 describes to find an inverse, we switch x and y. So let's do that. So I'm going to take like 4 or 5 coordinates, and we're just going to switch x and y. All right? So what's the coordinate right here on this graph? 0, 0. If we switch x and y, real exciting. 0, 0. Okay. The coordinate on the parabola here, 1, 1. If we switch x and y, okay, this isn't exciting yet. How about this one, negative 1, 1. If we switch x and y, that becomes the coordinate 1, negative 1. Okay. Here we have the coordinates 2, 4. So in the inverse, it would be 4, 2. And then the coordinate negative 2, 4 on the inverse would become 4 negative 2. And I think we have enough. Okay, that would be our inverse. Does anybody have an issue with the inverse?
Wouldn't that technically be a radical, and radicals can't go below, square, it would be square root, radical square roots can't go below the x-axis.
Okay, so you're saying like this portion right here is a square root, right? And you could say like this would be like a negative square root, right? That's kind of what you're trying to describe to me? Okay. Good. I like that you recognize that. Basically, to draw that, you're saying we would have to draw it with 2 different functions, right? Okay. What if we look at the red graph as a whole, like one equation? What would be true about that one equation? It is not a function, okay? And we're all about functions right now, okay? So technically, y equals x squared does not have an inverse. Because when we draw the inverse, it's not a function. Okay? Now, if we restrict y equals x squared to be half of a parabola, then that would be okay. All right? But technically, this is not an inverse because the inverse isn't a function. Now, you knew this wasn't a function, Eli, because it didn't pass the vertical line test. We have something called the horizontal line test. Does our blue graph, does our parabola pass the horizontal line test? Okay, if we think of the same rules as the vertical line test, can't go through more than once. All right? The horizontal line test, it does not pass. So what do you think the horizontal line test is going to tell us? Okay? Does our function have an inverse? If a function does not pass the horizontal line test, then it will not have an inverse. So I want you and your group to come up with 3 functions if you can. How about 2? 2 functions that pass both the horizontal line test and the vertical line test. You have like 30 seconds. I need a function that passes the horizontal line test.
Is this one you can count?
It doesn't have a verse.
Okay. Pod 5, give me one. Y equals X. Good. Pod 2, give me another one. Good. Pod 4.
Y equals x2.
And what one were you saying? Those functions all obviously pass the vertical line test because they're functions, but they also pass the horizontal line test. These are what would be called one-to-one. Okay? There is only one input per one output. Okay. So to be a function, we know that we can only have one output per input, okay? But now this is saying we can also only have one input per output, okay, to make it past that horizontal line test. So these functions are really special because they are one-to-one. They are functions and they have an inverse. So I want you to remember that a full parabola cannot have an inverse. That will be important. Can half of a parabola have an inverse? Yes. So that's square root functions. Okay. So we're going to do two algebraic examples. Okay. I know you've done this before. There will be an example that you probably haven't seen. But then we're also going to talk about domain and range with the inverse function. Okay, so we are going to start with this one right here. In preparation for tomorrow, let's think about what this graph looks like. Kira, this is a square root that has been shifted where? To the left 2. So I'm just going to make a quick little drawing here. Okay, we're going to come back to that guy in a little bit. Okay. Okay, so back to pod 1 description. To find an inverse, we need to switch x and y, and then you went ahead and said solve for y, right? So I'm always going to give you a function and function notation. I would go ahead and change the f of x to y. So then you could switch the x and the y. Okay, so technically this is the inverse, but we need to solve for y so we can write it in function notation. Okay, so what's our first step in solving for y? What? Square both sides. Don't be afraid to speak up. All right, we need to square both sides. So we have x squared equals y plus 2. X squared minus 2 equals y. So what I want you to write is that f inverse is x squared minus 2. Okay, now you are going to have to determine the domain and the range for this inverse function. What kind of an equation do we have here? X squared minus 2 is a quadratic. And typically when we see quadratics, what do we see on the graph? A parabola. Is this inverse a full parabola? It is not, okay? I urge you to consider the domain and range of the function before you think about the domain and range of the inverse. Okay? So let's come back up to the function itself. Okay? If our function is this square root of x plus 2, okay, Maverick, what would our domain be for this one? Good. -2 to infinity. Okay? And then our range, Lindsay L., what would that be?
-2 to infinity.
Did you say -2?
Oh no,
So range, we're thinking about our y values, right? Where do our y values start if we're looking like up and down?
0.
Yeah. So we're going to go 0 to infinity. Okay? So that is the domain and range for our function. When we go down here to the inverse, what do we have to do with the domain and range of the function? Switch it. So since the domain is -2 to infinity, the range of our inverse is -2 to infinity. And since the range of our function is 0 to infinity, the domain of its inverse is 0 to infinity. What's happening? Hold on. Is that our inverse is just that half of a parabola. Make sure you think about the domain and range of the function before determining the domain and range of the inverse. If it's a nice parent function that has been shifted, transformed, okay, it should be quicker for you to think about because we've been working with those parent functions and transformations. Okay, I do not mind if you make a quick little graph in order to determine the domain and range. That's why we've gone through all of that transformation process. All right. Ready for the fun one? I urge you to pay close attention and take careful notes on this problem. You will see one like it again. Now this is one I do not expect you right now to know what the graph looks like. In chapter 2, we're really going to spend time graphing these. Maybe you have an idea of what the graph looks like, okay? But you at least need to know one thing about this. And what's the one thing I need you to pick out from that equation? What did we work on yesterday with anything with the quotient? Okay, we cannot have 0 in the denominator, so we can at least figure out what our domain is, okay? The domain of this original function is what? Anything except -2 because that is where our denominator is 0. Okay? Okay, so first step, go ahead and write f of x as a y. And then the inverse, we are going to switch x and y. What? Oh, okay. I don't know if you had a suggestion already. Nope. Okay. How many of you feel a little bit of an anxiety because there are two different y's? You can be honest with yourself, okay? There's two different y's. How do we solve for it? Okay? First of all, there's a fraction. Okay? I don't really want to work with a fraction. I want to work with something that's more linear or quadratic. Okay? So what could we do to make it so that there's not a fraction anymore?
Multiply both sides.
Okay, so you're saying like multiply by this? Okay. If we multiply by y plus 2 over y minus 3, these are going to cancel over here. But what's going to happen over here? There's still going to be a fraction, isn't there? So you have the right idea, but let's tweak it a little bit. Okay, Maverick, how should we tweak it?
Just multiply by y plus 2.
Okay, let's just multiply by the denominator. That way there's no fraction. Okay? So our denominator is gone on the right side. And on the left side, we're taking y plus 2 times x. So we get xy plus 2x because we'll need to distribute that through. Now, how will we solve for y? There are two different y's we have to worry about. Any ideas or suggestions? How about this? If we have two different y's, should they be on the same side of the equal sign or opposite sides of the equal sign? Probably the same side, right? That would maybe make a little bit of sense. So what I'm going to do is I'm going to keep xy over here, and I'm going to subtract this y over, and then I'm going to subtract the 2x over to the other side, so that on this side I have terms with a y, and on this side I have terms without a y. Okay. Now, if I want to solve for y, what can I do on the left side of that equation? We can factor out the y. So if we have two terms with something in common, that gives us an opportunity to factor. Once that y is factored out, okay, that x minus 1 is tied by multiplication, so we can go ahead and divide it over. So what I need from you is that the inverse is negative 2x minus 3 over x minus 1. You will have a problem like this in your homework, okay? I need you all to try to get all the way through it. Okay? If you get stuck in your homework, come back to your notes. If your notes don't make sense, you can come back and watch this video on my website. Okay? Now, let's talk about the domain and range of the inverse. Okay? All the way at the top, we decided that the original function had a domain of everything except -2. What does that tell us about the inverse? That our range is everything except -2. Okay. Now, in our first example, I made you find the domain and range of the original and then switch it for the inverse. Okay? Since we didn't know how to graph the original, we thought about the domain because we knew that. So we could make it our range for the inverse. Now, since our inverse is also a quotient, we can easily fill in the domain from here without having to know the range of the inverse. Okay? So if we look at this fraction, we know the domain is everything except 1 because that's where the denominator is 0. So our domain is everything except 1. And now we're okay. All right. Your homework is on your gold sheet, so don't feel that you need to copy that down. Okay, it should be on your gold sheet for you. Tomorrow is function aerobics. All right? We'll come in here. We'll go over questions from the homework, and then we're going to move all the desks to the sides and back of the room, and we're going to do function aerobics. It is what it sounds like. Okay? We are going to be making graphs with our bodies. Okay? I would suggest if you can help it, like ladies, don't wear a skirt or dress. I would not wear like high heels. I would wear, we're not going to be like running or anything, okay? But you will be moving around the room. So dress appropriately, okay? I will be wearing a sweatband and like I'm going to go all out for this. You don't have to, but feel free to be creative, okay? There may or may not be prizes involved tomorrow. We'll see. Okay. All right, we have 10 minutes left in class. I'd like you to go ahead and you can work on either your quiz corrections or this homework. Anyway. Yes. Can you flip the light switch on your way out?